Hi, Andrew here. I'll be talking about perception as optimal prediction. So in chapter 12, Ramachandran says that the perceptual system follows a rationale something like this. Given the available information, it is 90% certain that what you are seeing is a lion. Therefore, for the sake of argument, I'll assume that it is a lion and act accordingly. Now, he seems to be channeling Helmholtz here, who said that perception is an act of inference based on incoming sensory data and our prior experience. But Ramachandran doesn't say anything more about this. He doesn't explain what it means to be 90% certain at a perceptual level or to make an assumption at a perceptual level. So I started looking into this. First, I read the textbook that we used last term. It says, a role for the massive input from V1 to the LGN has not been clearly identified. One hypothesis is that top-down modulation from the visual cortex to the LGN gates subsequent bottom-up input from the LGN back to the cortex. Now this is interesting for a number of reasons. It says there's a hierarchy in the visual system, there's bidirectional flow of information, and there's this top-down modulation happening, gating bottom-up input. And it's alluding to some hypothesis. So what hypothesis is that? And also, how do we reconcile this with the deduction that perception is inferential? Well, I think the hypothesis they're alluding to is hierarchical predictive coding. The idea here is that predictions about what is out there in the world is encoded, and that signal goes downward in the hierarchy and it meets with the incoming data, and the extent to which there's a mismatch between the prediction and the incoming sensory data is the extent to which there's an error. And that error signal propagates up the hierarchy so that better predictions can be made to eliminate the error signal. And that's what happens according to the theory. This message passing continues until perception error is minimized throughout all levels of the hierarchy, thereby affording a Bayes optimal representation of sensory causes at multiple levels of description. Okay, but now what is Bayes optimal? What does that mean? Bayesian optimality entails maximizing the probability that a hypothesis is true given the evidence. So this formula is an application of Bayes' theorem, and it basically captures the transition from data to knowledge. It is a formula for optimal inductive inference. So if your perception is Bayes optimal, then you're the least likely to be wrong about what you're seeing compared to all of the other possible hypotheses that you could have come up with about what those data in the world entail. So what kind of evidence is there for this? Well, it seems like most of the evidence involves a computer model based on this hypothesis of predictive coding and Bayesian optimality. And then the computer model is compared to people and animals. In this particular study, they had ferrets, and they were measuring the activity in the visual cortex as they look at natural scenes, and then also as they look at just nothing, just a blank screen. And they did this over a developmental period and showed that the activity in the visual cortex decreased at each later stage in development, theoretically because there is less processing of an error signal, because they are making more and more optimal internal models of the environment, i.e. their matrix of predictions about what should be in the world is becoming more and more accurate. Well, here's a study involving humans in an fMRI machine looking at movement on a screen, trying to predict the movement. Basically, again, there's less activity in the visual cortex when the movements are highly predictable. So the idea is there's just less error signal propagating up to the visual cortex, which results in less activity there. And then here's another similar one. We have motion illusions as optimal percepts, and it's just showing that even though we can be wrong about what is actually happening in the world, about what those data out there mean, we can still be optimal because they compared the way we're wrong to the way a machine learner that is Bayes optimal is wrong, and it's very similar. And then finally, this is the paper that kind of got it all started, predictive coding in the visual cortex. It says here, when exposed to natural images, a hierarchical network of model neurons implementing a predictive coding model developed simple cell-like receptive fields. A subset of neurons responsible for carrying the residual errors showed end-stopping and other extra-classical receptive field effects. So that's a kind of evidence saying that this model system is similar to the real system, in some respects at least. So, in conclusion, what should we make of this evidence? Well, you can consider it a kind of proxy evidence, or if you're pessimistic, a kind of fake evidence for the sake of argument. I think that we need a different kind of evidence, empirical evidence that comes from recording from massive numbers of neurons simultaneously within neural populations at different levels of the hierarchy of the visual system, for instance, and that we're about to get to the point where we can generate data in that way, that kind of evidence, and analyze those data to try to discern how is uncertainty encoded, how is prediction encoded, how are error signals encoded.